Hello everyone, it's Miss Williams, and this is Chapter 7, Section 1, What is a Sampling Distribution? So we have a couple vocabulary words that you need to definitely be familiar with. Parameter and statistic. A parameter is a number that describes some characteristic from the entire population, whereas a statistic is a number that describes some characteristic from a sample. So if you're talking about a number that represents a population, you would talk about the parameter. If you're talking about a number that represents a sample, you're talking about a statistic. So we all know that when you take different samples, you can have what's called sampling variability, and that is the value of a statistic varies in repeated random samples. For example, if you wanted to take the ACT score of a random sample of 15 seniors at McGavock High School, the first 15 you picked would have a different ACT average than the next 15 you pick. That's called sampling variability. Sampling distribution of a statistic is the distribution of values taken by the statistic in all possible samples of the same size of the same population. So a sampling distribution would be if you took every group of 15 seniors at McGavock High School and you figured out their ACT average, and then you plotted all that stuff on a graph. That would be your sampling distribution. When you describe a sampling distribution, this should look familiar. You want to talk about shape, center, and spread. Some things you need to know. An unbiased estimator is if the mean of the sampling distribution is equal to the value of the parameter being used. How spread out you are. Low variability is better. So if your sampling distribution has low variability, it's better. And the variability of a statistic described by the spread as its sampling distribution. This spread is determined mainly by the size of the random sample. Larger samples give smaller spreads. The spread of a sampling distribution does not depend much on the size of the population, as long as the population is at least 10 times the size of the sample. And that's important. We'll use that a lot to make sure that the population is more than 10 times your sample. And this is something you need to write down on your paper. So obviously, you definitely want all your arrows or whatever, your darts, to hit the center of the bullseye. So A shows a high bias but a low variability because all your dots are really close together, but they're biased because they're not where the target should be. B has a low bias because all the dots are centered around the center, but high variability because your dots are pretty spread out. C has high bias and high variability because the dots are spread out and they're away from the center. And then ideally, what you would want is low bias and low variability, where all the dots are together, really close, and they're also very close to the center. Okay? Quick lesson. We will do some more practice problems in class.